Now let's look at graphing square root functions. So to start with, let's just look at y is equal to the square root of x. And let's look at the basic relationship of that. Well, the first thing that we notice is that x has to be greater than or equal to 0. And the reason is because otherwise you would end up with the square root of a negative number, which you can't do unless you use imaginary numbers. So the second thing let's do is we can do a little table of values to get a sense of what it looks like. We don't do this every time, we just kind of memorize what it looks like. Let's start at 0, the square root of 0 is 0. And let's look at 4, 9, 25, and 100. Well, if x is 4, then y is the square root of 4, which is simply 2. If x is 9, you plug a 9 here, you get square root of 9, so that's 3. 25, you get 5. 10, you get 100. What you basically end up with, we'll draw it more carefully in a minute, is you start off with 0, 0. At x equals 4, you're at 2, so that's 1, 2, 3, 4, 1, 2. That stays there. And then what happens is you have to increasingly get larger and larger and larger. So if you go way out here, when x is 100, y is only 10. So that's the basic idea. If we want to do it more carefully on a table, we can. Though these, more often we do just conceptually, as opposed to actually graphing it out by scale, partly. So if we think about this, we know we have 0, 0. Let's just use this table we have right here. We have 0, 0. You have x is 4, so that's 1, 1, 2, 3, 4. Y is 2, so that's going to be there. And the next one is 9. That's 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's even graph that in there. That's 4 and that's 9. That's going to be 3. You get a sense of what it looks like. The graph is roughly going to look like this. And that's y is equal to the square root of x. This point right here is 0, 0. This point right here is going to be 4, 2, 9, 3. The domain here is that x is going to be positive. And the range is y is going to be positive. Now, domain and range is actually done in the following video, so we won't worry about that now, but we're just worried about graphing it. Now, here's a point that's not at all clear. X and y both continue to increase. And it looks like, the way we draw this, it might be that it gets so flat that y stops increasing, but that's not true. This is the basic graph of y is equal to square root of x. So let's say we want to graph in particular, let's say we want to graph y is equal to the square root x plus 3 plus 5. In general, this is going to be in the form y is equal to a square root x minus h plus k. The h here is going to move it left and right. And the key is it changes signs. The key with the k here is the k is going to move it up and down. But the key is it moves it up and down and it doesn't change sign. And the a does two things. The a, if a is negative, it will flip it. If the absolute value of a is greater than 1, or the absolute value of a is between 0 and 1, that's going to make it, it's going to make y increase faster or slower. So in some sense you can think about this as steeper and this as flatter, if you want to think of it that way. But really what you can do is you can just plug in some numbers and then see it. So you don't really have to pay attention to what a is so much as long as you plug in some numbers. So let's go ahead and graph this. Y is equal to x plus 3, square root of x plus 3 plus 5. The first thing that I would do is identify the vertex, if we want to call it that. It's not actually called the vertex. It's kind of the starting point. So you get a vertex or starting point. That's the equivalent in our basic graph of the 0, 0. So we're going to take this and we're going to move it around and where the 0, 0 goes. And the vertex is always going to be hk. So in this case, the starting point is going to be a minus 3, positive 5. Remember, the h changes signs and the k doesn't. Now let's look if it opens up or down, or if it flips or not. This doesn't flip. So I'm just going to sketch it now and then I'll draw it in a second. You know it's going to start at minus 3, 1, 2, 3, 1, 2, 3, 4, 5. So it's going to start at minus 3, 5. And it's not going to flip, so it's going to look something like that. To graph it a little bit better, we're going to make an XY chart. Now, on the XY chart, start with the vertex or starting point if you want to. You might want to call it starting point to remind you that it's not a vertex. That's minus 3, 5. Now, choose some x number that's more positive than a minus 3. Now, since it's a square root, you could choose a number that'll be easy to calculate. That's kind of up to you. I'm going to choose a 1. Because if I choose a 1, that's 1 plus 3 is 4. And that'll be easy to do. And the next number I'm going to choose is going to be 6. So let's plug these numbers in to see what we get, right? We have the starting point. Let's plug in y equals 1. So if y is equal to the square root, just take the original problem and put a 1 where the x is. That's the square root of 4 plus 5, and the square root of 4 is 2, so that's 2 plus 5, or 7. And now let's plug x equals 6, so you get y is equal to the square root of 6 plus 3 plus 5. Now, I happen to choose the numbers so that when I did the square root, I always got an integer. It doesn't matter. If I would have chosen another number which isn't that way, I just use a calculator. And in the next video, I'll do that. So that's square root of 9 plus 5. Square root of 9 is 3. And 3 plus 5 is 8. So that's 8. So what do? I find the starting point, because it's just hk. The starting point is hk. That's minus 3, 5. And that's what I did first. Then I chose any two x values I wanted to. I chose 1 and 6. And then I plug them in. If I can do them without a calculator, I do them without a calculator. Otherwise, I don't. So now let's go ahead and graph the whole thing. So to review, we have y is equal to the square root of x plus 3 plus 5. I have this table right here, right? So the starting point, let's graph the starting point first. The key here is that you know the starting point and you know the general shape of the graph, and that's going to turn out to be enough to get a pretty good graph. So let's go ahead and graph minus 3, 5. So that's 1, 2, 3. That's minus 3. 1, 2, 3, 4, 5. So that's the point right there. Then I'm going to graph the point 1, 7, 5, 6, 7, 1. That's going to be the point right there. And then I graph 6 and 8. 1, 2, 3, 4, 5, 6. And then that's 1, 2, 3, 4, 5, 6, 7, 8. That's going to be right there. Key is that you start here, draw a line there. You don't know exactly what it's going to look like, but basically it's going to increase and it's going to get flatter and flatter as you go along. You probably want to label your points here. This is minus 3, 5. This is 1, 7. And that's 6, 8. And that's how you graph square root functions. And there's a following video that says more graphing square root functions to watch, and then there's a following that says domain and range.